Let's solve some questions from circles and tangent. The first question is an MCQ. In the given diagram, RT is a tangent touching the circle at S, and angle PST is 30 degree, angle SPQ is 60 degree. We have to find what is angle PSQ. So PSQ is the missing angle. Now let's look at what theorem might be useful to solve this question. First, let's look at angle PST, which is 30 degree. So this is an angle between my tangent ST and my chord SP. So there is a theorem stating that the angle between a tangent and a chord is equal to the angle in the alternate segment. So here the angle in the alternate segment is angle PQS. So this angle PQS has to be equal to angle PST. So we have a 30 degree here. Angle PQS is 30 degree. Then if I look at my triangle QSP, I can use angle sum property and say that angle PSQ plus the remaining two angles, which are 30 degree plus 60 degree. This will be 180 degree. So I will find that angle PSQ must be 90 degrees. So which is option D. Moving ahead. In this question, CE is a tangent and ABCD is a cyclic quadrilateral. Then there are two other angle measurements which are given, angle ABC and DCE. We have to find these three missing angles. First, let's look at angle ADC. So angle ADC. Okay, so if I look at my cyclic quadrilateral ABCD, I know that the opposite angles are supplementary. So here angle B and angle D are opposite angles of my cyclic quadrilateral. So I will say angle ABC plus angle ADC equal to 180 degree. So since it's a descriptive question, we have to write the statement along with the reason. So the reason here I'll write opposite angles of cyclic quadrilateral. And then I can find that angle ADC will be equal to 180 minus 93 degree. So which is going to be 87 degree. So this is answer for the first part. Angle ADC is 87 degree. Alright. Next they're asking us to find angle CAD. CAD. Okay. So to find angle CAD, I can look at what is angle DCE. So DC is 35 degree and DCE is the angle between my tangent CE and my chord CD. So again I will use the theorem that the angle between the tangent and the chord is equal to angle in the alternate segment. So here my angle in the alternate segment is actually angle CAD. So that will be equal to angle DCE, which is equal to 35 degree. So the reason I will write angle in alternate segment. Okay, done. Then the last is to find angle ACD. ACD, this angle. Then for that I can apply angle sum property in triangle ADC. So if I look at triangle ADC, I will say that angle ACD plus the sum of the other two angles, which is 35 degree plus 87 degree, is equal to 180 degree. Angle sum property. Okay. So angle ACD plus 122 is 180. So angle ACD will be 180 minus 122, which is going to be 58 degree. All right. Moving ahead. Okay, so this question, it's given that O is the center of the circle, AB is a diameter, and if AC equal to BD, so AC chord is equal to the length of BD, and angle AOC is 72 degree, we have to find these three angles. So let's look at finding angle ABC. Angle ABC. So if I compare angle AOC and ABC, angle AOC is the angle subtended by arc AC at the center, and ABC is the angle subtended by the same angle at the remaining part of the circle. So the angle at the center will be double the angle at the remaining part. So I can say that angle AOC will be 2 times of angle ABC, or I can say angle ABC will be half of angle AOC, which is half of 72 degree, which is 36 degree. And the reason I will write that angle subtended at center is 2 times angle subtended by the arc at remaining part of the circle. Okay, so first part ABC done, 36 degree. Okay, now let's look at how to find angle BAD. BAD, okay. Fine. For this, let me join the radius OD. I can do this construction in the figure. Okay, now there was a theorem from 9th grade which said that if I have equal chords, in this question AC and BD are my equal chords, so equal chords subtend equal angles at the center of the circle. So if AC subtends angle AOC, which is 72 degree at the center, then the equal chord BD will also subtend 72 degree at the center. So BOD will be 72 degree. I will write that reason that angle BOD must be equal to angle AOC equal to 72 degree. Equal chords subtend equal angles at the center. That's the theorem. Okay, then if I compare angle BOD and BAD, BOD is the angle subtended by the arc BD at the center, and BAD is the angle subtended by the same arc at the remaining part of the circle. Now I have already used this property in the first part of the question, so I don't need to explain that again in detail. So I will just say that therefore angle BAD will be half of angle BOD, which is half of 72, which is 36 degree. So angle BAD is 36 degree. And then the last part is to find angle ABD. So for ABD, I can look at my triangle ABD. So looking into triangle ABD, angle ABD plus the remaining two angles. Here the remaining two angles, one I have already found out, BAD was 36 degree. So this is 36 degree. And angle ADB has to be equal to 90 degree. Angle ADB has to be 90 degree. The reason that AB is a diameter that is given to me. So angle ABD plus the other two angles are 36 degree plus 90 degree. This will be equal to 180 degree. So here the reasoning, one is anyway angle sum property, and the other reasoning is that I have used angle ADB equal to 90 degree, and the reason here was this is an angle in a semicircle. So all these reasonings are important for us to write in the solution. Okay, then if I look at it, angle ABD, if I calculate, must be equal to 90 minus 36, which is 54 degree. So that is answer for the last part. Okay, moving ahead. In the given figure, I have two tangents, TP and TQ, with center O, and then two angle measurements are given. BCQ is 55 degree and BAP is 60 degree. I need to find angle OBA and OBC. OBA and OBC. Alright, so let's focus on that first. Since we have two tangents given to us, and let's say that OA is a radius, PA is a tangent. So angle angle OAP will be equal to 90 degree. Reason is radius and tangent are perpendicular at point of contact. So therefore angle OAP is 90 degree, and it is given that your angle BAP is 60 degree. Therefore angle OAB, this angle OAB will be 90 minus 60, which is 30 degree. So OAB is 30 degree. Then if I look at triangle OAB, I know that OA and OB are equal because they are radius of the same circle. So it becomes an isosceles triangle. And we know that base angles of isosceles triangle are equal. So I will say that angle OBA is equal to angle OAB equal to 30 degree. So this is 30 degree. So reasoning, there are two reasons. One is OA equal to OB radii, and we have base angles of isosceles triangle, okay, which are equal. Fine. So one answer is 30 degree, OBA is 30 degree, and then in the exact same way I can find out what is angle OBC. So I have QCB 55 degree, and also OC is a radius, QC is a tangent. So angle QCO will be 90 degree. So I will be able to say that angle, this is angle OCB. OCB will be 90 minus 55 degree, which is 35 degree. Okay. Then I have again the same reasoning. BOC triangle will be isosceles, so base angles will be equal. So therefore angle OBC is same as angle OCB, which is same as 35 degree. I don't have to write all the reasoning again because the reasoning is exactly the same what was explained to find the previous angle. So I have found out these two angles, OBA and OBC, 30 and 35. Then they're asking to find angle AOC. Angle AOC. Angle AOC is the angle subtended by arc AC at the center. So that is double the angle ABC. So I will say that angle ABC is 30 plus 35, which is 65 degree. So therefore angle AOC is 2 times of angle ABC, which is 2 times of 65 is 130 degree. And you need to write the reasoning which we have seen before. So that is angle AOC, which is 130 degree. Then to find angle ATC, I can look at quadrilateral AOCT. So in AOCT, I have two 90 degree angles. The reason is OA, OC are radius and AT and CT are tangent. So they will be perpendicular. So I have two 90 degrees, I have a 130 degree. So if I look at angle sum of a quadrilateral, it adds up to 360 degrees. So I will say that angle ATC plus 90 plus 90 plus 130 is 360 degree. Angle sum of quadrilateral that you can mention. So therefore angle ATC must be 50 degree. Then let's look at the last question. In the given figure, ABCDE is a pentagon um, inscribed in a circle such that AC is the diameter. And we have parallel lines BC and AE. An angle BAC equal to 50 degree. We need to find these three angles and then prove that BE is also a diameter. Okay, so let's look at ACB. ACB is over here. Now, since it's given that AC is a diameter, therefore ABC has to be 90 degree. Then I can look at triangle ABC and use angle sum property to say that angle ACB plus 50 degree plus 90 degree equal to 180 degree. So angle ACB must be 40 degree. So the first part is done, 40 degree ACB. Then to find angle EDC, okay, I can look at my parallel lines first. BC is parallel to AE. So this angle ACB is equal to angle EAC. Angle EAC is equal to angle ACB. The reason is these two angles are alternate interior angles looking at the parallel lines and the transversal AC. So EAC will be also same as 40 degree. Then I have a cyclic quadrilateral ACDE. In cyclic quadrilateral ACDE, opposite angles are supplementary. So angle EDC plus angle EAC is equal to 180 degree. So EDC plus 40 is 180. I will say EDC will be 180 minus 40, which is 140 degree. This is answer for the second part. Then we need to find angle BEC. Now angle BEC is this angle here. I can join AC, BEC, and angle BAC, which is given as 50 degree. They are the angle in the same segment BC. So BC must be equal to angle BAC, which is 50 degree. So this is the third part. Now, if I look at trying to prove BE is also a diameter, I have to look at whether angle BAE is 90 degree or not. So if I calculate angle BAE, it is 40 degree plus 50 degree, which is 90 degree. So since angle BA is 90 degree and we know that angle in a semicircle is 90 degree, it implies that BE is a diameter. So such simple proofs can also be asked along with finding the missing angles.